Welcome everybody. Can you hear me okay? So today we're going to talk about building load side distribution options. And I'm Melanie Stachowiak with ME Engineering. Our panel today is Jason Filler with Webb. He's going to talk about the kind of the refrigerant side. Justin Jobe with Enertech, talking about the hydronic. Paul Selking with water furnace. He's going to talk about kind of six pipe, and then Tim Mutkoski with ClimateMaster, distributed heat pumps. So Jason's going to get started.
Yeah, make it official now. Mm-hmm. All right, now we get started. All right, my name is Jason Filler with Webb. I'm a sales engineer. And we're going to talk about water source VRF. Feel a little funny talking about VRF in a geothermal conference, but it does have a great application here. Here you can see a picture of the condensers in the mechanical room. They go from anywhere from 5 tons up to 26 tons in a single condenser, and you could do a bank of condensers to go up to about 45 tons. The 5-ton units, 5 tons and under, they come single phase. Anything above 5 tons is going to be 3-phase. The good thing with these water source heat pumps in a VRF application is it gives you a lot of flexibility. So here's a picture of the smaller units of these 5-ton units inside it's really inside a wall, to call it mechanical closet. And then you got your flow station on the right there, and this is in a residential application here. So when we look at the VRF, you have all the same options you would with the air source VRF system, all your different indoor units. So this is really good for retrofits where you might not be able to get ductwork in, or the existing hydronic can't handle lower water temperatures. You have all these different indoor units you can use, and you can either do a heat pump, so you're either heating or cooling, or you can do it as a VRF, so you can have simultaneous heating and cooling. Another option with doing a water source VRF is these hydro kits. So this is a refrigerant to water heat exchanger. And we can do up to 175 degrees hot water. So again, lean more into that retrofit. If you got existing baseboard, existing radiant, you don't need to change all that fin tube out. You don't need to change out fan coils. You can have one of these units to make that hot water for you. So again, kind of helps with the limiting factors of a traditional water source heat pump where you only get about 130, 140 degrees at best with that. And these units you can tie to, I don't have a picture of that, but these units you can tie to other indoor units. So you could have a 4-way cassette, you can have a wall-mounted unit, and then have this tied to that system. So you're also taking that rejected heat, pumping it back into your water system there, and getting free heat. So you got a lot of options with this. So here's a design using these hydro boxes, a domestic hot water system. We got two condensers on the left, and on the right where it says DHW, HU, those are the hydro unit kits. So these units are making 140 degree water. One thing should be noted is right now, currently the condensers are 410A, and the hydro units are 134A. So we got 2 different refrigerant circuits going on right now. Obviously that refrigerant is going to change going forward, but at least for the rest of this year, this is what we have. And these units are set up in a multi-pass system. You can get up to a 25 degree delta T on them, and then we're just circling it through the storage tanks you see there on the right-hand side there. Here's just another schematic of another hydro unit domestic hot water system showing the multi-pass piping. Again, the water's going in the tanks. We're trying to mix that tank as much as we can, circulate that water, and force water back to the hydro kits to mix with our incoming water. And we're going to circulate that until we get to 140. And as there's sensors in there, so as the temperature drops, the hydro units and the condensers are going to kick on to maintain that 140. So here's some limitations on the units. The single phase units, your total pipe length, you're limited to 656 feet. Your maximum elevation change is 98 feet. And then on the three-phase, you get a little bit more flexibility on it. You know, total pipe length, 1640. Max pipe length to your furthest indoor unit is 558 feet. And then your max distance is 164 feet between your outdoor and indoor unit. So you can put these on the roof, you put them in basement mechanical room. You have a lot of options with these units. And then when it comes to your entering water temps on your source side, they can operate down to a really low water temperature. You're talking down to, you know, the performance chart says 14 degrees, but there's not much heat in water at 14 degrees. So, you know, if you keep it around 30 degrees, it's a pretty safe operating parameter right there. Again, you can operate in heating only or continuous operating range, so you can see your options there. It's a really robust unit, and it helps a lot. Maybe you have a geothermal field that's kind of drifted too far one way. You can use these to add heat back into that bore field. And then last slide here, here's a schematic of this. I believe I was an office building where they use water source condensers in the base mechanical room. And I just want to show you here kind of the different options you have. You know, they weren't able to put anything on the roof, so they want GEO, and these units sit in the basement, and then each floor has their own condenser. Some have two. That third floor is a little bit bigger. But you can see you have a mix and match of different indoor units. You got, those circle units are the 360 cassettes. You got some fan coils, and you got some four-way cassettes in there. And you got all the refrigerant transfer boxes in there, so we're doing simultaneous heat and cooling with these units. So again, this is really a good application for if you're working in an old house, you can't get ductwork in there, working in a historic building, any place where you might have trouble kind of putting a new system in, the Samsung is a really good option. And it's not just Samsung. Not trying to make this a Samsung pitch, but all the major manufacturers make this. So LG, Mitsubishi, this is kind of a standard thing from the VRF manufacturers. That's all I got for you today. Thank you.
All right, is everybody still awake after lunch? Things are going well? All right, perfect. So my name's Justin, I'm with Enertech. I'm gonna talk a little bit about variable speed hydronics as it applies to residential systems and light commercial. For years in this space, we have prioritized comfort over efficiency on every single level. And this goes down to the way systems are installed, the methods that we use, the way we pipe things. And so I'm sure most people in here have seen projects that look like this. I generally, as much as I love these kinds of things, and I have tons and tons of pictures like this, it's kind of plumbing porn, but it scares people away from doing systems like this. And it's not accessible for most residential customers and even in the light commercial world. There is a new era with hydronics, allowing technology to work for you and allowing heat pumps and all of the cool pumps and various things that we have available to us today to do a better job of installing things, cutting down on labor cost and fittings and pumps and pump watts and all the things that are included, and not losing or sacrificing any of the comfort of the home. So currently, apparently, well, as most of you probably already know, I'm a little bit biased when it comes to this. So, you know, I'm going to be talking about our heat pumps, but there are other products on the market. So this is a new variable speed water-to-water unit. It is a ground source unit, and essentially the easy way to think about this box is it does anything from 40 to 140 degree water. And so anything you can heat or cool with those temperatures, this is capable of doing. We offer electric backups as well as dual fuel options available. And we like to think in the hydronic space that this is actually future-proofing buildings. Not to pick a fight with the guy that went first here, but with VRF systems piping refrigerant through a space, as we all know with the refrigerant changeover right now, that's kind of a sticky situation. And there will always be devices to heat and cool water. So putting hydronics throughout a building, whether that, you know, what that looks like in 50 years from now, it's hard for me to know. However, I'm confident that there will always be a way to heat and cool water. So it's really kind of future-proofing the load side distribution of that project. There's also heat pumps out there that are air-to-water heat pumps, as well as using some hydronic kits on other, mini-split and VRF systems. But variable speed air-to-water heat pumps are an emerging technology that, especially here in the Northeast, there's definitely a lot of incentives and a lot of call for this type of system, and these things make for a really great boiler replacement. The benefits of this, we have huge labor savings and space savings. We do direct-to-load piping with no buffer tanks. So when you cut out the buffer tanks or hydraulic separators, you are cutting down on your pump watts, you're cutting down on the labor to install it, the floor space that you need to install a system like this. When you separate the hydronic coils for air conditioning away from the refrigeration circuit, you can get a lot better dehumidification because you have full control over the fan speed at that point. We can do things like up to 100% domestic hot water, and we can get heating, cooling, and domestic hot water from a single unit. It really is kind of the ultimate flexibility. We can get the same amount of BTUs through a 1-inch water line that you can through a 10x14 duct. And so when it comes to being able to remote mount, ceiling cassettes or high wall units or low wall units or, radiant floor, there's really endless use cases where hydronics is really kind of the best answer. So with doing things like direct-to-load piping, it's really kind of changed the game, and I'll show you some pictures of a few install examples. But when we talk about the flexibility of this product or these types of products, traditional, whether it be high mass radiant, embedded tube in concrete or staple up, any number of fin tube radiators, panel radiators, whether they're decorative or not, hydronic air handlers, the same type of head designs that you see for mini splits and VRF, those are all available from various manufacturers for hydronics. So it really just opens up a whole new possibility of options that really anything you could do with a boiler, a furnace, an air conditioner, or any various conventional style heat pumps, you could do with hydronics today. We do, like I said, up to 100% of the domestic hot water. We personally do this with a reverse indirect hot water heater, but there are multiple different ways that this can be done. And so we get kind of the best of both worlds of having some stored mass there, but keeping it in a small package. And when I talk about how simple this can be, this particular very simple drawing is just showing the load piping going out to something like a radiant floor and a fan coil. Because we're going direct to load, the load side pump is internal to our heat pump, and so we're just putting on 2 motorized ball valves. You're just hooking up the pipes, supply, return. Everything else is handled for you within the box. So we receive calls separately. We can work off of outdoor reset, which is built into the unit, and we just receive a heat call, a cool call, or a radiant floor heat call, and distribute that water in the amount that's required. This is a true variable output system. We can go from the smallest zone that we have operating on one right now is a hydronic towel warmer, and it's operating at 0.8 GPM at around 1,800 BTUs per hour. So I get asked that question all the time, what's the turn down rate for these heat pumps? And with current technology, it's pretty incredible how low you can go, with the maximum output being around 72,000 BTUs. So when you compare this to the pictures that I showed earlier with walls and walls of pumps, and you think about all the flanges and ball valves and wiring and all the stuff that it takes to install systems like that, we can do stuff that's really complex with a whole lot of zones by just putting in motorized ball valves and no more high voltage wiring, just running variable speed pumps. So the game has kind of changed here. This one here is a little bit more complex. This is an air to water system, and this one I show it in a dual fuel configuration here. Showing it just kind of as 2 radiant zones, but it really doesn't matter what the zones are, and also doing the domestic hot water. So again, this is a direct to load piping configuration, super simple, really easy to hook up, and cuts down a ton on labor and components required to install a project like this. Here's an actual install of the ground source water to water unit. This particular project here, there's actually 4 zones on here, plus the domestic hot water. And this one does have a boiler backup, and that's it. That's the extent of the mechanical room. You can see it's very, very different from what these jobs used to look like when you had multiple heat pumps sitting there and buffer tanks and pumps, and this is just a much cleaner install, much easier, faster, and cheaper, ultimately. Here's a little larger system. We've got 2 heat pumps sitting here. This one here's got a total of 4 air handlers and 4 radiant zones, or 5 radiant zones, plus doing domestic hot water. And again, this is the extent of the mechanical room. Now, there are remote mounted air handlers throughout this home, but this is a larger residential home. And for anybody in here that has any experience with doing, a project like this, the older way of doing this with buffer tanks, this mechanical room would have looked very, very different than that. And last but not least, we have an air to water system here. This one here is running 2 heat cool air handlers and 4 radiant zones. Again, all direct load piping, also doing domestic hot water. And this one again has a boiler backup on it. So just showing a couple of examples of what this could look like in a home in comparison to what most people think about when they think about a fully hydronic home. And we have a lot of people doing this today, replacing boilers, as well as just replacing furnace and air conditioning systems to take advantage of the air-to-water heat pump and how efficient it is for domestic hot water. So there's a lot of options out there, and I appreciate your time. Hopefully that was quick enough. Thanks.
So I thought I'd start with a question, see if everybody's still awake, if you can figure out what is in common in the tri-state, New Hampshire, Vermont, upstate New York area between all these sites: Ithaca Community Schools, Salmon River Community Schools, Burlington Community Schools, Ithaca Guthrie Hospital, Bard College, Hudson Valley Community College, Skidmore College, SUNY Alumni Hall, SUNY Sullivan, SUNY Cortland, OnLogic Commercial Office, Reed Commons Multifamily, Elderly Services of Vermont, and Kimball Union Academy. And it's not that they're all in those 3 states either. They all have 6-pipe chillers on geothermal systems. And part of what my message is going to be, to talk a little bit about how do those systems maybe add to a design that you're thinking of or could be used in a building that you have. And we'll talk a little bit about some of those considerations to take into account, and then end with a little bit on a specific application that hopefully you'll find useful on one of your own sites. So we do have at Water Furnace, and some other manufacturers also have products that provide this type of solution, and lots of different piping options with these. We're going to talk today a little bit about the 6-pipe variety, as that works, I'll say, the best with a geothermal system in providing both chilled and hot water, and then utilizing the source of that geothermal loop to your advantage. One of the nice things when you really think about doing this is I've got to figure out from an engineering perspective how to retrofit. The majority of the work out there, right, is retrofit. Very few times do you get a clean sheet of paper to work off of. So one of the great things about modular chillers is just that, they're modular, right? So I can come in and I can get them into the space that otherwise maybe was built around in terms of a large boiler stashed somewhere in the basement or some other place of this building itself. The other thing about it is that you can also kind of build. I've watched several presentations already this morning where they've either been halfway through or there's future work to come, and you can add the piping side right away at the beginning, so then as you expand the footprint of that building, all you need to do is bring in the equipment and connect it up to the pipe rack that's already installed there. So it gives you a little bit of future proof and some nice flexibility as that building changes, or as the use changes, right? In some cases, a building's use changes from one style to another, and it requires more capacity. One of the great things about having these modules is now I can really adapt to the different changing building that happens day to day or hour to hour even. And in the case of utilizing this and utilizing modulating water valves on the back side, now we can really drive in the heating or the chilled water appropriately, and we can do it by only energizing the compressors that are required at that point in time. So you kind of see some examples on the screen there, whether it's a predominant heating load or a predominant cooling load, right? We like to say any module, any mode, any time. And that's one of the beauties, that within that same module, I can be providing a portion or all of the heating, and then some or all of the cooling, and vice versa. And we a lot of times will refer to that as simultaneous mode. And it's just a great way to leverage the electrical watts that you're putting in, because if you're familiar with a vapor compression cycle, right, that costs money to operate that compressor. But if I have to do that lift one time, and I can take advantage of both sides of that lift equation, now, right, I've got a very nice COP or EER, depending which one you're looking at, because I'm only having to do that lift one time, and I'm taking advantage on both sides of the water side, the hot water and the chilled water side. So we'll activate that right down the line here. You see this example showing the first one. As the capacity or the demand requires additional units to be brought on board, those will be done and managed as you max out each module in a stepped manner. So let's step into a case study, because I'd say this is probably the majority of the applications start very similar to this study, and that is that you've got an existing site that's got some type of boiler in it for the hot water, and you likely maybe have an air side or some type of cooling tower doing some cooling. So you have multiple devices throughout the building or even outside of the building. And what you want to get to, whether it's regulatory or whether it's owner-driven or just doing the right thing for the environment, you'd like to get to, right, a lower footprint for that building. And so what we would simply show here is that if you have a GEO loop, now what I'm doing is I've got that modular chiller in there. I've eliminated any need for the outdoor equipment, and now I'm leveraging that loop. So I've got those water valves on the back side of that unit, and when I've got a need to do heating or cooling or both, and I've got any excess BTUs that are not required by the building, I can just send those back out to the loop. Again, right, it's just a big battery sitting out there that I'm putting my energy into and pulling my energy out of to maximize, again, the footprint and the requirements of the building. In most cases, we almost always recommend that if you've got an existing building that has some level of boilers in it, to go ahead and leave at least one of those in place for a backup solution. If you were in one of the earlier sessions that GeoFees gave, Connor was doing a presentation where they were tracking a building. We don't recommend, though, as Connor's system showed, that you let the controls guy, though, go in October, and because he doesn't believe in geothermal, turn on the backup boiler full time, as Connor showed with their example, which is a great reason why you do want to monitor these systems. But we definitely recommend to try to keep that boiler in place, because then you do have a backup solution. The other thing that you can do to think about from a design perspective when you have a boiler already in place to utilize as a backup can be when you're trying to plan out what your loop field size should be. So many times, right, we'll see individuals design the loop field for the full worst design condition day, and it may drive extra hundreds of thousands of dollars or more into the loop design. And if you've got a backup available and you can use that to trim off your last 2 worst days, right, of your temperature profile, you could actually have a very nice little hybrid system that actually saves the owner quite a bit of upfront costs, but still no impact on the building and the comfort level of the building. So just a couple neat ways that you can leverage this type of system because it is modular. You can add to it, and you can also, if you have availability, leverage that gas boiler that's already in the system. And with that, I'll hand it over to Tim.
So, full disclosure, I'm only 3.5 months with CCG, so I'm still a little bit euphoric about my new company. Sometimes you don't get the new job, you still love the job. It didn't go south quick, but just a little bit about us. First, myself, I'm 30 years plus in the industry, as my name tag rolls over, and I was mainly with Train and Carrier. I've come to CCG, and just a slight thing that I really love is all our product. We have 6 manufacturing locations, 4 brands, and they're all made in Oklahoma City in the United States. I say that from a perspective that it's very fun to be able to walk the lines of all that, but it also allows us to be a little more customizable when we do things. And what we find with a lot of the systems, especially with geothermal, you need to customize a little. You can't have a cookie cutter product that's not going to necessarily work all the time. And so that is a great part of having a local factory. Now, when I interviewed with the job, I had always dabbled in geothermal with my previous companies. ClimateMaster and CCG, they're very highly focused on this. This is their kind of like their pride and joy a little bit. So when I started to get into it, what I did, I knew it was in residential and I knew it was in education, but it's really in places that you don't expect it. And you see, there's not a building that you cannot probably put it in. And when only 10 years ago, you would say, no, we can't do it there. We can't do it there. And when you look at some of the places that actually have geothermal, you're like, wow, I didn't realize that. And it's starting to get bigger. So we have a site in Oklahoma City. It's 34 acres under one roof, 100% geothermal. We have a building in New York City, 36 stories, geothermal. So it's starting to become more and more common to see us push the envelope of where you can put it. Now, I didn't put even a manufacturer here because there's many manufacturers. And this line, I would say, if I looked at everybody, we all have that same kind of graphic for most of us that make water source heat pumps. In the background there, you're going to see some of the larger units. And when you put the larger units in, this leads to one design, which is, if the building asks for it, you're putting one unit in and you're ducting out. It sounds like a rather conventional system, but sometimes that's what you need for the building, and it's all geothermal. If you go back to this, you have many, I call them incremental units. So you look at the center one, that's a console unit, looks just like a fan coil, goes under the window. How many people are staying in the hotel here? A few people. You have a high-rise unit. Now, I didn't go to check if it was a high-rise fan coil or a high-rise heat pump, but nevertheless, it's a high-rise unit and fits in. All these products, I have the slim there. We make them so small that they're 9 inches height now, because you have to fit in places that were pre-existing. So you can do retrofits with geothermal as well. So all these add up to that you could find a system that's going to work for your building. Now, this would be a typical setup of a geothermal system, and generically, we're just going to look, all right, those are units. They could be a console unit, they could be a high-rise heat pump, they could be a horizontal unit. It doesn't really matter, but we have our source, our drilling source down at the bottom there, and we're spreading it out. So what used to be a boiler in a tower is now ground source. It's combined, and you can easily do both. And there are times, I should say, I'm going to take a step back. When you look at this, we do simultaneously heating and cooling. Where have you mostly heard that from? You've heard that from VRF manufacturers. You could do simultaneously heating and cooling. Geothermal and heat pumps, you could do that all the time when you use incremental units. It's a very easy thing to do. And so we have a lot of flexibility, and look at the places that need that. I mean, you look at a hotel as a perfect example. You're going to have one room that's calling for cooling, one room that's calling for heating. It's an easy thing to do in a hotel to do this. You look at just an office space, And I always laugh because I used to get involved in high-performance buildings when I was younger in the industry, and we would do some crazy designs. I say they were crazy. That doesn't mean they were bad. They were just crazy designs, and we're going to make these high-efficiency buildings. And if you did an audit years later, you would find out that they were operating horribly inefficient because of the amount of people that would bring in their own electric heaters or fans to supplement what the units weren't doing, or what the person needed in that space. And so when you're able to do simultaneously heating and cooling and set up that space, you avoid that. You could do a hybrid system. So we know geothermal, and immediately somebody thinks it has to be 100% geothermal, but we can't always get there. Sometimes there's reasons you can't. You may have a very high heat-dependent building. You may have a very high cool-dependent building. So you could still add a tower. You could still add a boiler. Some engineers want to do belts and suspenders. I grew up that way. But you could manage it as you want. You do not need to be 100%. Now, oh, that's interesting. When I was doing it, it didn't have the graphic this morning when I was looking at it. So we know, for the most part, this is our system when we do a heat pump system. We have the geothermal water, or the condenser water, going in, and then we have it leaving. And so this is normal, and down below it shows conventional tower and boiler. But imagine that's the geothermal, that's the heat sink into the ground. And this is how we do it. Okay, and this is how we've done it for years. However, there's been another way to do this for years that we don't always take advantage of. And when we're looking at a geothermal system that might be slightly more expensive to put in on a first cost basis, we can always look at a single pipe loop system. And when I came over to this company, CCG, I had never heard of this before. And I said, where in the world have you done this? And the answer was thousands of sites across America. So it's not like it's something new, but it may be new to you. And it's one riser up. You're breaking off to the floor, and you have, each unit has its own miniature pump. And that goes on, takes the water it needs, and shuts off when it doesn't need it. The temperature of the pipe may go up and down depending upon what unit's calling for heating, what unit is calling for cooling. But at the end of the day, you're designing for some of the peaks, so you're not worried if they all call for cooling at once or they all call for heating. But what you've done is you've saved yourself all that first cost installation of that extra pipe that you never needed. And this system, by the way, is used on fan coils, chilled water systems all the time. It's actually done more often on chilled water systems. And in prominent buildings in Chicago, in Washington, D.C., it's not an uncommon system. And so you save that, and you wind up actually saving energy doing this too. Because those little pumps only go on, they're very energy efficient pumps, they only go on when you need them. So those are just some designs if you're doing it, and I kept it short, and that's it.
Is there any questions from anybody? Start over here. Yep.
You tell me where.
Right here.
State your name and who you work for.
Hi, my name is Aditi Parlikar. I work for LNS Energy. My question is for Justin. What is the standard dollar per ton kind of amount that you have? That's a conclusion, basically, for multifamily residential projects and small commercial projects when it's a new construction, pretty much.
So you said dollar, is this on?
It's dollar per
Okay.
ton.
Dollar of the install cost or operation cost? Install cost is a pretty hard thing to judge just based on the distribution system. I would say, I mean, from the equipment side itself, we're probably, well, again, we're talking geothermal versus, air to water. I don't really have a great answer for you there because I would just need more information about the project. And then where it's at, obviously geothermal cost here in New York State versus geothermal cost in Nebraska are two wildly different prices. So I don't really have a good a good just kind of overall, but we definitely can help out. If we knew a little bit more about the project, we definitely have people that could help out with that and give you a base, you know, or a good gauge to go by if we had some of that info, so. Multifamily, new construction, upstate New York, yeah, it's hard to know exactly. If you reach out to us, I could get you some more information. I would just need to know what kind of distribution system. Are we talking forced air or hydronics, or, you know, what this would look like exactly? But I can definitely provide some more info for you if you could give me some info about the building or space.
We can take another question.
All right.
If you had one here.
Hi, I'm Vincent Spiteri with National Grid. Jason, do you have any idea when the sizing guides and specifications might come out for VRF systems with the new A2L refrigerants?
The air source stuff should be out now. That product's going to be released next year. We're able to do equipment selections now for engineers and for owners. The water on the hydro units, we don't have the information yet. That's 134A. That is going to be phased out too. I don't know what that refrigerant's going to be. A lot of the VRF, probably most of it, is going to be all R32.
Mm-hmm. So the R32, when would that come out?
It's going to be released next year, the R32. But we can get you design specs and guides now if you need it.
Gotcha. Thank you.
Thank you. There's one in the back here.
Tony Gelber, Pratt Institute. So we're looking to put wherever we can, wherever we have a chiller, take it out, put in a heat pump chiller, hopefully a GEO heat pump chiller. You talked about simultaneous heating and cooling, and it seems to me in a lot of our systems, we can't do that even because our current systems aren't set up that way. So am I missing something here? Now, where we have a dorm with P-tax, yes, each room gets its little compressor or heat pump, and they could do simultaneous heating, cooling. But so am I missing? I would love to be able to tell everybody, yes, we're all going to get simultaneous heating and cooling. Yeah, I'm the greatest, but what are your thoughts?
I'll assume that based on those comments that you have mostly a two-pipe changeover type setup, so you're either sending chilled water to those units or you're sending hot water depending on the season. And definitely to take advantage of both sides of simultaneous, you either have to have various two-pipe systems or a four-pipe system to leverage to be able to utilize and do simultaneous. So, you know, if you've got multi-buildings that you can utilize that in, or if you have a four-pipe system in the building, then yes, you can take advantage. If you don't, so maybe that connects the dot of what your question was.
So yes, if two-pipe, I understand it. Now, where we have four-pipe, is our heat pump chiller going to do? Can we send out heat, hot water, and cold water?
That's correct. Yeah. So it's going to be providing both sets. It's going to meet both set points, and the way it's going to do that is there's a water valving on the back side. So on the actual header rack itself, on the plumbing side, then that valve is going to modulate to meet that temperature on both the hot side and the chilled water side. And then to ensure that it doesn't overshoot or undershoot, it'll send any additional water back to the loop, back to the GEO loop. So that's how it's going to meet both set points at the same time.
Thank you.
No, good question.
I think we had one on the aisle here.
Elizabeth McCorvey, Family Resource Center. ClimateMaster, are any of your machines, does anybody make a machine other than the company out in Ohio that does direct refrigerant? And what do you guys think about the copper pipes going in the ground? I heard some stories of stuff failing compared to the HDPE piping. So what's the recommendations? Be nice if ClimateMaster, that Ohio company with the direct refrigerant made use the HDPE with the pipes instead of copper. Can you speak to that? Thank you.
Okay, I think most of us could speak to it, but I don't think we'd be putting copper pipes in the ground. I think we would pretty much all agree on that that's not the case to go. You want to use something else. As far as the direct refrigerant, I don't know specifically what you're referring to.
Yeah, direct transfer. They're using the ground. So for those that don't know what she's referring to, it's burying copper tubes in the ground and using the ground for the condensing side. So you're actually running the refrigerant through those copper pipes. There's been many companies over the years that have done this with various levels of success. I would say there's the one company that she referenced out of Ohio that still does it to this day. In the grand scheme of things, in the geothermal industry, I mean, technically what they're doing is geothermal heating. It's a pretty niche market. And I'm not trying to downplay what they're doing, but it has some pretty significant challenges. And with the A2L refrigerants, it's getting increasingly more difficult. So, if that works for you, it's not a real simple install to do, and the life expectancy of it is not ideal. So, that's really kind of where that stands. Paul, do you have anything you want to add about that?
Nothing to add.
Okay.
Any other questions? I have a question. So one thing I wanted to ask is about outdoor air. How does each of the systems address outdoor air with those systems? Like what kind of solutions do you guys have?
Outdoor air temperature?
No, just like providing ventilation to the buildings.
So as it applies to our equipment, we rely on third-party, generally ERVs to provide ventilation. We certainly work with them on some controls, but none of our products are specifically designed to facilitate that ventilation process on its own. But
I can take this next. On the water furnace side, so we have a full line of products on the water source heat pump side that come with a energy recovery wheel in them. So kind of go from about 2,000 CFM up to 8,000 CFM, or about 10 tons of mechanical cooling to 30 tons of mechanical cooling. And those can be what we would call twin together. So you can actually keep adding them together. They'll act as one unit all the way up to about 75 tons of mechanical cooling in that. And so we currently build all of our products, including that one, in our Fort Wayne, Indiana facility, of which we're proud to be opening here in about a week, a 170,000 square foot expansion too. So they all are built right there, including our DOAS product.
For ClimateMaster, we're a little bit of a hybrid. In some of them, we are partnering with other ERV manufacturers, and in some of our product, we are providing the ERV in the product. So it's going to be product dependent, case by case.
And for the VRF, typically we'll use a ERV. Sorry about the noise. We're going to use an ERV or a DOAS unit. The DOAS unit, currently you can tie that into your VRF system with a third-party coil, and we can control that through our existing controls. And you're not stuck to, if you have a Samsung system, you don't have to use a Samsung ERV. You can use any ERV system you're comfortable with in VRF.
So one more. I got 2 fingers in the pie. So outside, good question. We're in New York City, and so we've been thinking of, we're looking toward this kind of central system so we can avoid the fire department and the refrigerants generally. But then if we put ERVs or HRVs up on the floors of the buildings, we run into this limit on the amount of refrigerant we can use. So how do we, are you seeing that as a problem, or you've solved that problem? Like, we got a dorm, we want to put 1 ERV or HVR per floor, but these refrigerants become, flammable and problematic. So what's the solution to that, or is it solved?
There's no simple solution to that. When you get to those larger buildings, I would recommend to do a third-party DOAS unit, decouple it from your VRF system so all the refrigerant is contained into that unit. When you start, running long line sets, multiple floors, you're obviously gonna have a lot of refrigerant. So that does complicate things. So again, you can just do a separate DOAS system or do ERV units, a high efficient ERV unit where you have a higher supply air temp off the core on each floor and just kind of, again, decouple it from your VRF system. It's gonna become more and more challenging with these A2Ls to have long line sets and time to your air handlers. It just, like you mentioned, unleashes a whole new set of regulations and codes. So I think we're gonna see a lot more decoupled systems with the VRF systems going forward.
Yeah, I think we got one up front here.
Hi. So for the heat pump plus ERV systems that you have installed, have you been able to leverage any existing NYSERDA or state incentives that have lowered that install cost for customers?
Yeah, I'll take it. Yeah, absolutely. I mean, it's not so much, with because it's VRF and ERV, it's just the energy savings and going all electric is where we've seen the savings. You're familiar with NYSERDA, so anything all electric, we're getting incentives on. But far as like a VRF versus a water source heat pump, anything like that, they're very similar in their capacities and efficiencies. So it's just a matter of working with the owner and, consultants on getting those rebates through NYSERDA.
Got it. Just wanted to ask if there's heat recovery specific incentives that you've seen.
I haven't seen anything specific for heat recovery systems, for the simultaneous heat and cooling VRF. I know NYSERDA just added to the clean heat program heat recovery chillers this past year, so that falls in with Paul's 6-pipe chiller. I know that was a struggle when they first came out because it was a new product to the market, so having them understand that it's a heat pump, but it does more. But now it seems to be solved with NYSERDA.
Yeah, I'll jump in here too with the incentives for the utilities. They do have like a bonus program through the clean heat that if you have energy recovery, you can kind of get a bonus. It bumps up the incentive dollar value per MMBTU if you're applying for that. Any other questions? There's one in the back here.
Repeat customers here. Anybody with a new question?
I was going to ask if there's any, in cold climates, if there's any concern or how that's addressed.
So no concern from our end of things on cold climates, especially on the ground source side. As long as the loop is sized for the size and performance of the building, there won't be any issues. And when it comes to air to water and a lot of the cold climate air source stuff out there, I mean, most of them are capable of going down to depending on the refrigerant they're using, minus 13 C or minus 13 degrees Fahrenheit or minus 25 C is kind of typical for 410A. It's going to be really similar for 454B and R32. So that's kind of the low end that you're looking for or looking at for those products.
Yeah, I'd probably add to that and just say what I talked about at the very end is really almost cold climate proof. If you think about adding it in a way that you have that boiler for that worst design day condition, clearly the entire unit, just like Justin's saying, is all inside the building. So, right, we're using the ground loop that's buried for all the reasons you're all here at the NY-GEO conference and understand. But then additionally, if you just think about how to do a hybrid system, it could be really the ultimate cold climate solution because you're not killing your COP that an airside solution is going to have in that cold climate. Even the best one is not going to have near the operating efficiency in that cold ambient condition, whereas we're really immune to that whole setup with our setup being all inside, under the ground, and then if you want to use that boiler as the backup, your carbon footprint is going to be, way reduced versus the alternative.
I agree with that.
Yep, John Excuse me, John Thomas with Water Furnace. Jason, I'll preface this question by saying it's a highly loaded question because of my bias. And you're up there with, 3 water source heat pump guys, but you sell a few of those yourself, I think. So you shared some new information, at least from my perspective, on kind of the timing of how VRF, air source VRF, is responding to the legislation that requires them to be compliant by January of 2026. So we're moving forward on the calendar here, which is 1 year later than the rest of the industry. There's no doubt VRF, air source VRF with distributed refrigerant, you got 3 ways to move energy around a building. You can move it with water, you can move it with air, you can move it with refrigerant. No doubt of the success that VRF has had over the last 25 years in taking space on distribution and energy in buildings. What's your forward view of how you see that playing out? Because water source and distributed refrigerant have kind of been on a bit of a battle, I would say, over the last 25 years. How do you see that going forward, and how do you think about that? And I'm not trying to steal your thunder, because I think you're up after this talking about state regulations, but curious as the trend that you would see.
Yeah, I mean, no doubt it's going to be challenging for VRF going forward with A2L refrigerants, and down the road there's stricter guidelines with refrigerants, so that's going to make it even more challenging. I think what you're going to see is smaller VRF systems with less refrigerant charge instead of doing a big 60-ton VRF system with heads all over the place. Maybe you'll see systems per floor just to limit that refrigerant charge. And I think honestly you're going to see a lot more water source heat pumps, a lot more water side distribution, whether it's just distributed heat pumps or fan coils in each room. There's definitely going to have to be a change in the way we approach these building designs for sure.
Hi, Lauren Kroll from Sustainable Westchester. This is probably a question for all panelists or whoever wants to answer, but I'm curious about what the strategies to date have been for consumer side engagement around these products, and what have been the main motivators that you've noticed when it comes to talking about, distribution options.
I can talk about this a little bit, as well as these. We actually pair up on some consumer side marketing strategies. It's really difficult, to be honest with you, and geothermal heat pumps is not the coolest or hippest thing to talk about and market on social media and that kind of thing, but the people that are into it are heavily engaged. So I think our industry as a whole has really kind of been met with some pretty significant challenges, and trying to figure out the best ways to go to market and educate consumers on what is possible. There's a lot of misconceptions and kind of stereotypes around the geothermal and water source heat pump industry, and a lot of that is driven by the contractors. And so, like we see the same faces throughout this industry. I travel nationwide and go from state to state, and it's always kind of the same characters. And you have, in every state, you have these geothermal champions that do a wonderful job of educating people. But then, you have just as many people out there, if not more, that are talking negatively, or not speaking negatively. They just don't know anything about it, and because of that, they're afraid of it. They don't want to talk about it. So I think there are challenges there when it comes to trying to educate consumers. We make up such a small portion of the overall HVAC market that we don't have the marketing budget to really have massive impact and do like a nationwide marketing campaign. Hopefully one day we're going to get there. But yeah, I think we do the best that we can, and I'm confident that these two guys over here and the companies they're with do the same that we do. And like I said, we do partner up on a few marketing efforts like NY-GEO and Geothermal for All, which was a couple years ago. So it still remains to be seen, I guess. We're still working on it.
Yeah, you mentioned NY-GEO, so if you get the chance down on the first floor, right when you walk out, right there in kind of the main area of the folks that are displaying, you'll see the NY-GEO stand there. So please stop, and Eric Trickian is leading that effort, right? Several companies are contributing actually several $1 million to that marketing effort, right, to get the word out to your question. And I'm sure Eric would love to talk to other like-minded individuals of ways to help that mission, to use the strategy we're talking about of Mission Geo, because it is a way to try to get more advocacy and more understanding amongst the general public, homeowners to building owners. It's not just residential, it's residential and commercial in terms of trying to get the word out, and right, always open to more companies like ourselves to join forces on that through some of those consortiums. Great question.
Well, I want to thank you, panel, and thank you, everybody. It's been really informative.